So Jean-Marc, you also heard from yesterday. He's an author and developer of the French carbon accounting method called the Bilan Carbone Assessment Tool. And he's the co-founder of Carbone 4, an independent consultancy firm that specializes in low carbon strategy and climate change adaptation. And Jean-Marc will continue his presentation from yesterday, going more deeply into the relationship between energy and economic power, and why it's so urgent for us to start allocating more funds to constrain climate change now.
Thank you very much. Although I'm not an economist, I might also say some nasty things on some economists, and I fully agree with what has just been said. The Group 3 of the IPCC should never have been set up, never. So I'm going to take from where I was yesterday. I'm sorry, I didn't put on the correct date. And I'm sorry. And I'm going to generalize what has just been said and recall where classical economics start from. Some of you might remember this guy. With a number of his colleagues 2 centuries ago, he set the basis of classical economics, saying that, actually, as you know, classical economics is looking at what is the limitation of the productive system. So we focus on the 2 things that are the first order limits on the productive system. And 2 centuries ago, 500 million people on Earth, all peasants, the 2 first limitations on production are the amount of arable land, that is capital, basically, and the number of people working, that is work. And at the time, the planet is almost infinite compared to the size of the human population. And so on the first order, you can say that any relative variation of natural resources can be considered as null. So this axiom has been written 2 centuries ago. It is still what is in the present economic models that have been sophisticated over and over on foundations that are now ill-stated. It's just like the Tower of Pisa, you know. If from the very beginning it is bending, then it's going to be more and more, I would say, unbalanced as you go up. So, because of what he had said, we today design economics in this very simple way. We have one production factor, which is work, another production factor, which is human capital, and there the supermarket is full. That's the way it works. Am I not right?
Pretty much, yep.
That's the way it is still taught in school. Okay. What I say is to get the supermarket full, you'd better have the resources that are going to be transformed to fill the supermarket. And you have to have the ability to transform these resources, that is work. But as I said yesterday, but I'm going to put figures behind, today, when you look at the work that is the transformation of natural resources, you come up with the figures that humanity counts for 1 when machines count for 200. That is, the productive activity of our species is done by machines. And there you understand that you can have 2 other limiting factors on the system. Capital is just an internal loop in this way to design. The first limitation that you can have is on the amount, not the price. I don't care about the price. The amount of energy, that is the amount, that is the size of the fleet of machines that produce for us. And then you will have a limitation on the GDP, even if you have plenty of workers ready to get up in the morning, and even if you have plenty of quantitative easing everywhere, so you can have plenty of capital, which are precisely the 2 things that we are doing today. And you can see that in the OECD, strong growth is not recovering as a result. And the other limiting factor that you can have is, of course, on resources. Let's take fishing, for example. If you have people that can invest in fishing boats, you have capital. You have people, sailors that are ready to go on the fishing boat, but you have no fuel oil, no fishing. You can't row, you know, on modern fishing boats. And if you have no fish in the sea that appear for free, no fishing. Those 2 elements, of course, are not in the productive function of fishing. Okay. So forgetting these 2 elements was not an issue for the past, because when you look at the past, you realize that actually it was possible to have growth, but precisely because of energy. Here you have a reconstruction, which is debatable, but it gives an order of magnitude of the world GDP since the birth of Mr. Jesus Christ. You can see that for 1 millennia, growth was not an issue because there was no growth, basically. The fleet of machines per capita was not increasing. the size of the population was increasing very slowly, and you had a plague once in a while that was decreasing the size of population. And so the world GDP was not really increasing. And you will also remember that in that period of time, there was no democracies. The question that I raise here is, will we be able to keep democracies in a world with no growth? Because, as you know, in democracies, you have elections. In elections, you have a competition in which everybody promises more for everyone. You never say, I'm going to give more to these guys and less to these guys, sometimes to the very rich, but generally it's more for everyone. This is something which is impossible mathematically in a world with no growth. Okay, so democracies in a world with no growth is an issue. Until the Industrial Revolution, you have very little growth, and then appear machines and fossil fuels, and as you see, we had 3% for eternity. Of course, we won't have 3% for eternity. And if you take a zoom on the recent period, I would say, since I have reliable statistics, I began to do something very simple 10 years ago. That was to plot the world GDP, of course in constant money, against the world consumption of energy. What is the world consumption of energy? It is the world fleet of machines. That's what it is. So what you can see is that the world GDP is a linear function of the size of the world fleet of machines, full dot. That's as simple as this. So the best macroeconomic model that I know is a straight line, and it says that actually the first limiting factor of the world GDP is the world energy consumption. That is today the first limiting factor. Actually, we have excess of work. There is unemployment everywhere. We have excess of capital. We have speculative bubbles and plenty of money that cannot be invested everywhere. So today, the first limiting factor is energy. And to be even more precise, you will see that the first limiting factor is oil. So because the Industrial Revolution was precisely going from renewable energies that were supplying 100% of the world energy 2 or 3 centuries ago to fossil fuels, and we didn't do that because we were stupid. We did that because the density of fossil fuel, of the energy content of fossil fuels, is incomparable compared to renewable energies. Fossil fuels are the only one that you can transport with you everywhere, that you can use whenever you want and wherever you want, and that enable to put in motion that Iron Man costume that we have manufactured for all of us. Okay. And because today it's fossil fuels that constitute the bulk of the energy supply in the world, you also have that quasi-linear relationship between the world GDP and CO2. So that pertains to what I said yesterday. There is absolutely no way we can address climate change with the correct order of magnitude, that is dividing the world emissions by 3 in 30 years, without triggering a world recession. There is absolutely no way we can physically do this. So today, saying that we are serious on climate change and that we will have growth, I'm sorry to say to this absolutely charming young lady, but it's a big fat lie. It is not something I'm ready to bet all my savings with everyone who wishes in the room that we will never get there. Never. So so this is the drama of the climate talks. This is the drama of the climate talks. Today, we're at the crossroads. We have to choose. Either we want stability over the long run, and then we have to contract the productive system, or we say, let's take advantage of that productive system for as long as it operates, but it's not going to operate for the eternity. And then the consequences will be whatever they are. And actually, because of the time lag that we have between emissions and consequences that I mentioned yesterday, there will be a time in history where we'll have less and less energy because of fossil fuel depletion. That is, less and less means to face adversity, and a growing adversity because of the inertia of climate change. This is going to be a very nice situation, and I doubt that it's going to harm the GDP for less than 3%. I think you can add 2 zeros to that. What you can see on this graph is also that not only you have a linear response in absolute figures, but actually you also have a very good response when you look at the annual change. On these 2 graphs, on the 2 curves, the green curve gives you the annual change, the year-on-year change of the energy supply in the world, the energy consumption in the world. So that is, again, the operating fleet of machines in the world. So it's the annual change of the size of the operating fleet of machines in the world. And the blue line gives you the year-on-year change of the world GDP. And so what you can see is that there is the two fit perfectly. And when they don't, there is generally a correction pretty soon afterwards. And actually, that fitting is even better for oil. So here you see two curves again. The red one gives you actually it's not a year-on-year change, it's a 3-year running mean, but it's exactly the same, regarding oil production. And it's oil production in volume, sorry. So it's the amount of tons, the number of tons of oil that you extract from the ground each year, and it's actually the variation. And the blue line represents the GDP per capita, the change, the year-on-year change of the GDP per capita in the world. And what you can see on this graph is that we do not have a GDP that increases because it comes from Mars. And then we use more oil because we can purchase it. What you can see is that the red variation happens a little bit before the blue one, which means that first we extract more oil from the ground, then we run more machines, and then we will have more production, and then we count this production with dollars, and it increases. And the fact that the two curves fit perfectly after the oil shock means that since the oil shocks, oil has been became the first limiting factor of the world production. So today, if you want a reliable forecast on what the GDP is going to be in the years to come, all you need is a reliable forecast on the oil production in the years to come. That is all you need. I began this work 10 years ago. It did wonders regarding my own predictions since then. So forget the economic models. They can't tell you that. And the reason why I'm going to generalize what has just been said by my distinguished neighbor is because I will come back to what I've just said yesterday and reformulate it in a different way. Nature gave us fossil fuels, again, for free. They form for free. Okay? Nobody in this room paid a single cent for fossil fuels to form. What we pay regarding energy is always the same thing. It's human revenues corresponding to the fact that we go and get the energy which is here for free. And those human revenues are both labor, have to pay the people in Total, Schlumberger, and so on, and people that happen to sit on the fields, for which either you pay them or you run over them, depending on the time of history. All the Middle East has been designed this way. We just came and said we're going to design the things this way. This is why the borders are all straight, because basically that's the way we have organized sharing the oil. So fossil fuels are free. As I say, they burn. They allow to transform all the rest. And all the rest has given us the socio-economic structure that we have designed in Western countries. Because of the fleet of machines granting us a huge productivity of work, we have plenty of free time that allows us to perform long studies, retirement, weekends, holidays, working only 35 hours per week in France, etc. All this is the result of energy. All this is the result of energy. So the way that we have concentrated people in cities because we don't need people in the countryside because we have tractors, this is also the result of energy. So energy is basically what has designed the modern world. And GDP only counts, it's not, again, and I insist, an asset. GDP is an annual flow. It's not an asset, it's an annual flow. You don't get richer because the GDP increases. If your revenue increases and your gambling in the casino increases faster, you don't get richer. Okay? You don't get richer. Only we have created a way to consider economy where we have only revenues and no expenses. The GDP is a system with no expenses. Okay? And we have at least two bottlenecks, actually. We have more, but two bottlenecks in this system. The first one is climate change. The second one, on which I think you should pay a little bit more attention than what is presently done in the Western press, is the upstream bottleneck. That is the supply of fossil fuels. Who knows in this room that conventional oil production peaked in 2008? Well, all the others should know it. All the others should know it. Including non-conventional oil, oil production in the world has remained flat since 2005. So today the swing producer is not Saudi Arabia anymore, it's shale oil in the US. Who knows it? Since a small minority in the room, okay? So the day shale oil goes down, which will happen someday, our production in the world goes down, and because I've just shown before, the world economy goes down. Okay, so it goes down again, I should say. So this is the way, and actually what Meadows did 40 years ago was precisely to design some economic thinking on the basis of what physically happens in the world. That's precisely what he did. And the very unpleasant result he came to was that there would be an absolute maximum to the GDP, something that classical economists escaped with the way they had designed the economy, so they can give ground to that illusion that we can have perpetual growth. But again, that is a fairy tale. It's an illusion. And to generalize what has just been said before, today, as natural resources are free, this has no price. And I fully share the conclusion that the Nobel Prize to Nordhaus is a hoax. Yep. It's a joke. It's a big, fat joke. If you don't have any price for natural assets, the price for the planet Earth is null, zero. How can you design a damage function on an asset which is worth zero? It's the only way. It's the only way. And even Lord Stern, for which I have a very profound respect, when he said that climate change could harm GDP up to 6%, he could have said 75 or 3. Same thing. I mean, in all cases, yep, like this, because again, you cannot design any other way a damage function on an asset which by definition, by axiom, has a value which is zero. You just cannot. And you can have very sophisticated functions after this stupid hypothesis. You will have stupid results. Okay? And people mix up the complexity of the model and the fact that the model is relevant. But it's very easy to design a very complex, stupid model. I can do that every day if I want. Thank you.